Okay, so this is the continuation on the introduction to networking part 1, exercise 4, layer 4 to 7 of the OSI model. So task 3, examine the components of application layer of the OSI model. Task you will examine the components of the application layer in the OSI model. To examine this, perform the following steps. So step 1, connect to PLA B110, which I am already connected to. So next is restore to the network and sharing center, which I am already connected to Windows, and click on Windows Firewall link. Okay, so let's click it. Okay, so step 2, click on Advanced Settings. Okay, so step 3, click on the inbound rules. In the left pane, view the middle pane, which contains the inbound rules. So step 4, look for the following applications layer protocols: core network dynamic host, these are just some of the applications layer protocols and services that are running on Windows device. These, and, these are network aware applications that service the user applications utilized by the person operating the system. Okay, so close the Windows firewall with advanced security. Windows firewall window. Okay, so let's just exit. Okay, so moving on to step 5. Right click on the taskbar and click Task Manager. Okay, so the Task Manager window appears. Okay, step 7, maximize the Task Manager for ease of use. Scroll down to the Windows Processes section and find a service. Okay, so this is the service host network service. Okay, so step 8, after expanding it, you can see that this process is responsible for the DNS client network location awareness as well as the remote desktop service. All of these are network applications and services that require this process to run. This process runs just below the network aware applications such as web browsers, email clients, remote desktop clients, and others such software packages. This is the application layer of the OSI model in action. Okay. Okay, so moving on to the next topic. So exercise 5. Contrast TCP and UDP protocols. Transmission Control Protocol, which is TCP in short, uses user datagram protocol UDP are protocols that work on layer 4 on the OSI referral model. There are different application layer protocols like HTTP, SMTP, FTP, etc. But how do they work? And what is the difference? HTTP, SMTP, DNS, and similar applications layer protocols use different layers for protocols and different port numbers to communicate. So for example, HTTP uses TCP port, which is 80. SMTP uses TCP port 25. DNS uses UDP port 53. TCP is a connection-oriented protocol. UDP is a connection-less protocol. In TCP, before end hosts can send data to each other, a TCP connection needs to be established between them. This makes TCP a reliable protocol because every packet sent needs to be acknowledged. TCP guarantees packet delivery. Packets sent over a TCP connection are checked for errors before they transmitted over the network. UDP is a connection-less protocol, hence it doesn't acknowledge packets and does not guarantee packet delivery. Packets are not checked for errors before transmitting them over the network. Applications that require high reliability, speed, and quick delivery of packets use TCP, hence TCP used for HTTP, SSH, FTP, email, and many others. UDP is used for applications that require a faster delivery and does not need to be checked for any errors, for example, voice streaming, video, DNS, and many others. In this exercise, you will capture packets and then identify TCP and UDP packets. To better understand this technology, also refer to your course material or use your preferred search engine to research this topic in detail. So, learning outcomes. After completing this exercise, you will be able to capture packets, identify TCP packets, identify UDP packets. So your devices, you will be using the following devices in this lab. So please power this on now. PLABSA1. Windows Server 2016 member server. Okay, so task 1, capture packet. In this task, you will capture packets to identify the protocol being implemented. To capture packets, perform the following steps. So step 1, connect to PLABSA01, then launch Wireshark from the desktop. Okay, on step 2, the Wireshark Network Analyzer is displayed. Okay, on step 3, select internal and click capture. Tap capture button in the top left of the toolbar. To begin capturing packets, so step 4, captured packets should begin to appear in the top pane. Okay, so in step 5, Wireshark windows display the details of data packets being exchanged among the device. You might not see many packets at first because there is not much traffic on the network. However, they slowly begin to appear. Scroll down to see an additional packets that are captured Notice the multicolor coding of the packets each color represents. As you can see. Okay, keep the Wireshark windows open. So so task 2, identify TCP packets. In this task, you will identify packets implementing TCP protocol and the ports used. Perform the following steps. So step 1, ensure that you are connected to PLVSA phone and the Wireshark window is open. From the Wireshark window, enter the following in the filter drop-down text box. Step 2, notice that the change in the color coding of the data packets. Only the data packets implementing TCP protocol are now being displayed. So there are several application protocols that use TCP such as HTTP and FTP. For example, any such protocols are also included and labeled as such in the list of captured packets since they use TCP. Select a TCP packet from the list displayed. The second page shows the details concerning this segment. Okay, so notice that the destination port in the following example, they are 3389 and 8651. Okay, keep the Wireshark windows open. So task 3, identify UDP packets. Okay, so in this task, you will identify packets implementing UDP protocol and the ports used. To identify UDP packets and ports used, perform the following steps. So step 1, ensure that you are connected to PLabs A01 and the Wireshark window is open. In the filter box, type UDP. Okay, so let's continue. Click on the white arrow button on the right. Then apply the filter. Okay, then remove this. Okay, so again, notice that the change in the color coding of the data packets, only the data packets implementing UDP protocol are now being displayed. UDP is used by several application layer protocols such as the HCP and TNS. Such protocols are also included in this filter list since they use UDP. Okay, step 2. Select a UDP packet from the list display. For example, select a DHCP. So let's expand this. Okay, hold on. I'm having a little bit of an error on the time on 2000 ms. Please check your. Okay, so is on expanding the user datagram. As you can see, the source port is 68. Destination port is 67. Okay, so moving on with our topic. Okay, so here's our new topic. Okay, on exercise 6, configure port 21 port FTP. File transfer protocol, short FTP, standard network protocol used to transfer files from host computer to another host over a TCP-based network like a private internet and intranet or internet on the internet. FTP is built on the client-server computing model It uses a separate data of control connections between the client workstations and FTP server. FTP users may authenticate themselves in the form of a username and password which are transmitted as plain text. For this reason, most FTP sites allow anonymous as the username and an email address as the password. FTP uses two port numbers, port 21 for data and port 21 for control. A server running FTP service listens on port 21 port FTP sessions by default. To better understand this technology, also refer to your course material or use your preferred search engine to research this topic in detail. So learning outcomes, after completing this exercise, you will be able to install web server, which is IIS role, set up an FTP site, verify FTP access from PLAB Win10. So your devices, you will be using the following devices in this lab. So please power this on now. PLABSA01 Windows Server 2016 member server. PLAB Win10 Windows 10 workstation. So task 1, install web server IIS role. In this task, we will confirm that while installing a web server, ensure IIS role on the server port 21 is configured for FTP by default. To install a web server IIS role, perform the following steps. So step 1, connect to Philips 1, okay, which I'm already doing right now, and click and start and search programs and files and box and type server manager. Okay, so step 2, on the server manager interface, click and add roles and features. Okay, so I'm ready to click add roles and features wizard. So step 3, add roles. Add the add roles wizard is displayed on the before you begin page. Read the information and click next. Okay, so step 4, on the select installation type page, click next. Step 5, on the select destination server page, click next. In step 6, on the select server roles page, select web server IIS. And add features from the roles list. When the add features that are required for web server IIS box appears, click add features. Okay, so I've already done that. Okay, moving on to step 7. On the select server roles page, click next. Okay, on select features page, click next. Step 9, on the web server role IIS page, click next. Then step 10, on the select role services page, keep the default selections. Scroll down to select the FTP server. Make sure that both the FTP service and FTP extensibility are selected as well. Sub-opinions for individual roles are given to enable you to select individual server roles if required. So click next. Step 11. On the confirm installation selections page, check the specifications for the installation and click install. Okay, the installation progress page displays the progress of the installation of the web service IIS role. So that's just it. Once the installation is complete, click close. Let's just wait for this to load.